to make the central point of how we as scientists can make progress in answering this basic question that the story of Vicky made very clear, namely, why can't chimpanzees speak? Now, this is a very old question. We're not the first to ask this. Aristotle already wondered why dolphins, with their large brains and obvious intelligence, weren't able to speak. And Aristotle concluded that it had something to do with their tongues. In fact, he thought the tongues were too rooted to the floor of the mouth. And as we'll see, this is actually the kind of hypothesis that many people still entertain today. So the two basic options, and Darwin had already considered both of them, is that there's something about the vocal tract, something about the anatomy, the external instrument that the sounds come out of, that is different in chimpanzees and humans, and that's what prevents chimpanzees from speaking. The other option, which I think many people find very intuitive, and this was in fact Darwin's conclusion when he considered this, is that it's something about the brain and not the vocal tract. And of course, it's possible that both play a role. So how do we go about answering this question? Well, let's start with the anatomy. We know today, and it was already known by the anatomist Richard Owen, that the human vocal tract is quite unusual. We are weird among primates, and indeed among other mammals. What this diagram shows you is an MRI of an orangutan, a chimpanzee, and a human being. And this red line indicates the position of the vocal folds, the larynx, the part of the larynx that generates sound. And what you can see is that in a chimpanzee or an orangutan, or indeed in a dog or a cat, the larynx is in a relatively high position, right behind the tongue, which rests flat in the floor of the mouth. In a chimpanzee, or indeed in a newborn human, the larynx can actually engage into the nasal cavity. So the larynx can stick up like a periscope into the nasal passages, enabling the animal to breathe through its nose while it swallows through our mouth. And we all started off life like this. We were all able to drink through our mouths, drink milk through our mouths, and breathe through our nose simultaneously. And that's because of this high position of the larynx. But quite early in human development, starting by the age of 3 months or so, the larynx begins to descend in the throat, pulling the tongue with it into this very peculiar sort of half-bent shape that characterizes all adult human tongues and is very different from that of a chimpanzee. Why does this matter? I hope these videos will be reasonably clear. What I'm about to show you is an X-ray video, a cineradiograph of me speaking. And what I want you to pay attention to is the contour right about here of the tongue in the mouth. So this is the jaw, these are my lips. I'll play it first at full speed and then I will slow it down.
A rainbow is division of white light into many...
Sorry, I don't know why.
A rainbow is division of white light into many beautiful colors.
So you can see the tongue twitching around, dancing in that cavity, in the oral cavity. And I'll show it to you again slowed down. What I would like you to pay attention to is this contour of the tongue and how mobile that is during speech.
A rainbow is division of white light into many beautiful colors.
So what we do when we speak is essentially pull our tongue back and forth and up and down and change its shape in a very rapid and very highly controlled way. The sounds that we produce, the vowels and the consonants that we produce, are a result of these highly coordinated motions. Now, the basic idea underlying the role of the descent of the larynx in human speech is that by pulling the tongue down in the mouth, we essentially get an additional degree of freedom, a back and forth degree of freedom, in addition to the up and down motion that, say, a dog or a chimpanzee would have, and that is the capability that gives us the power to generate this very wide variety of speech sounds. Now, this is a very plausible hypothesis. It fits with a lot of what we know about both anatomy and about the acoustics of speech. And it's based on a clear difference between humans and other animals. So it has all the marks of a good hypothesis. And this led my thesis advisor, my Dr. Vater, Philip Lieberman, to advance the hypothesis that this descent of the larynx, this lowering of the larynx down into the throat cavity, was the crucial thing that changed in our species and differentiating us from chimps that gives us the power of speech, that this is necessary and sufficient for speech in our species.